Okay, so back to here to finish up the Common Core Regents exam, June 2015. Um, so, completing a proof here. All right, so first we're going to do this proof, and then we will finish off with that. So, all right, first thing they give us is that this figure's a parallelogram, and we want the triangles here, these two. This triangle here, and that triangle there to be congruent. All right. So let's see. Because it's a parallelogram, we can say that these sides are parallel. Opposite sides of parallelogram are parallel. That's going to get us this pair of alternate interior angles. Remember, we've gone through this before. Look for the N in these inside corners, alternate interior angles theorem. We could have gone another way as well. We could have gone with the other ones, but this is the way I want to try to do this. And then we'll use vertical angles. And then the last thing, these sides are congruent because opposite sides of a parallelogram are congruent as well. So looks to me like it's an angle-angle side proof. And the reason it's not angle-side-angle is because that's the included side between these two pairs of corresponding angles. So since it's a side that's not between those, we're going to have to go with, got to put the S not in between. All right, so let's go through those steps. First thing I'd like to talk about is say that ABCD is a parallelogram, and because it's given. Okay, so you kind of make sure you establish that argument. We're going to use parallelogram later on, so we have to establish that argument. All right, so let's talk about, we'll do this at the same time. So AD is going to be parallel to BC, and AD is going to be congruent to BC. You can split those up, but I'm going to put it in as one because opposite sides of a parallelogram are both parallel and congruent. Now, reading some of my students' exams, their solutions, some students are saying the reason sides are parallel is because they have the same slope. That is true, but we are not on a graph here. This is a synthetic proof, not an analytic proof. Synthetic proof, we don't have any evidence that the slopes are equal. I mean, yes, parallel segments have slopes that are equal, but we don't have that as our justification. So don't say they're parallel because their slopes are equal. Can't prove that. Say they're parallel because of this reason. Opposite sides of a parallelogram are parallel and congruent. So let's fix that. Good thoughts that my students are having, but it's in the wrong place. Use that equal slopes idea when it's on a graph and you've calculated the slopes. All right, continuing. What do we get from this? All right, we get angle, and you cannot, this is another big mistake I see a lot. We cannot say angle A. There are three choices for angle A. This one, and the big one. We got to make sure we identify it using a three-letter path. So angle D to A to E. Now, if you follow along that, that produces this angle. Okay? So, yeah, let's keep going. All right, so then that one is congruent to, again, let's establish the three-letter path, D to A to E. We're looking at B to C to E. Angle B to C to E. Because alternate interior angles theorem, I will write that out though. Alternate interior angles are congruent when parallel lines are cut by a transversal. Okay, if I'm scoring it, I'm going to let you get away with alternate interior angles theorem, but not all teachers will. So just to play it safe, let's explain what that is. Alternate interior angles are congruent when parallel lines are cut by a transversal. All right, now that's a pair of angles. Up here we have a pair of sides. We need another pair of angles, which is the vertical angles. So angle, three-letter path again, because there's four choices for what angle E is. Let's see, what do I gotta? I gotta say angle AED, follow the three-letter path, and angle CE. What is that? A B up there? Yeah, angle CEB. Those are congruent by vertical angles theorem. Oops, vertical angles are congruent. All right. Now we have our angle side. Doesn't matter that we did the side first, okay? Um, but we still do have the triangles are congruent, okay? And then it's by the angle side triangle congruence theorem. Postulate theorem, whatever your teacher likes, okay? Some people use axiom even, so whatever you're used to. All right, describe a single rigid motion that maps triangle AED onto triangle CEB. All right, this is, let's see here. Um, it looks like we could use a 180-degree rotation, but we should be able to prove why. All right, they're already congruent, so we don't have to prove it. Let's just describe that. We don't have to justify it. We've proven they're congruent, so just describe it. Let's go with triangle. Got to get the right order. Okay, we're going to rotate triangle AED centered at, what's that middle point, E, by an angle of 180 degrees. Now we know for sure it's 180 because B, E, and D are collinear. Okay, so you're going to have to move 180 degrees to do that. So now when it says describe, it is not okay to just say rotate. That is not complete. You have to have a center when you rotate. You have to have an angle when you rotate. So make sure that we do that. All right, moving on to number 34. This is our situation where we have the three similar right triangles. You know, um, there is some math fluency that we got to achieve here. You know, we do need to know that this is a similar right triangles problem because that angle is definitely a right angle. Okay, they tell us that. So we've got to go back and make sure that we understand they're similar triangles. Okay. Let's see. They both, you know, they're talking through this. Camp to L, C to L is 0.25. Okay, C to L, and perpendicular. So they give us the angle measures are 90. The park ranger station to the campground. So P to C. Where is that? Okay, they labeled it for us. They put it right there. All right, determine and state to the nearest hundredth of a mile the distance between the park ranger station and the lifeguard. So they want P to L. All right. Let's see. Let's just pull that out. All right, that is a simple. Whoa. All right, sorry about that. Okay, that is right triangles, Pythagorean theorem problem. Oh, this is where they might catch some students. Yeah, this is PL. Let's just call it X. They might catch a few students with this because, you know, the hypotenuse is given. If you switched those without subtraction, you know, it could cause some problems. So, all right. And what do we have here? Let's see. This is 0.3025. We'll subtract. and x squared is 0.2400. We'll square root both sides to get rid of the squared. So this is just simple algebra. All right, we're at 0.4898 and so forth. Nearest hundredth of a mile. So it's going to kick us up to 0.49. So I'm going to write down P to L is 0.49 miles. 0.49 miles. Okay. Now, that's the first part. 4-point question, so there should be more. Let's see. Gerald believes the distance from the first aid station to the campground, that's F to C, is at least 1.5 miles. Okay. So is he correct? Let's figure out how far it is. Now, when we do this three right triangles problem, let me try this up here. Okay. There's a lot of ways to do this. Okay, so we could write similarity statements. We could try to match up corresponding sides, but let me just call this y. Okay. This is 0.55 and this is 0.25. So this whole distance is just perfect for us right here. Okay, if you check this out. This is the hypotenuse of the largest right triangle, and this is the hypotenuse of the smallest right triangle. So right now we have the hypotenuses of both triangles. Now, if we look, this is the smaller leg of the small triangle, and this is really the smaller leg of the large triangle. So we can use that to our advantage. We can set up a proportion because we have similar triangles, and that's what we're going to do. So let's go hypotenuse of the, let's put large over small, okay? Kind of give ourselves a key to follow, you know? So let's look at the hypotenuses first. It's large hypotenuse is y over small triangle's hypotenuse is 0.55. Let's go over to the small leg, but large on top. So on the large triangle, the smaller leg is 0.55. And on the smaller triangle, see this? 0.25 is the smaller leg. So these are corresponding sides. Okay. We want to cross multiply now. So it's 0.25y equals whatever 0.55 times 0.55 is. Okay, so 25y equals 0.3025. Is that right? Something doesn't look right there. Okay, it does. That's fine. Okay, so then that is supposed to be 1.21-ish. Okay. All right. So he is incorrect. Okay, Gerald is incorrect. The distance from F to, what is it, the campground? No, the lifeguard chair. What is it that he wants? No, the first aid station to the campground. Got it. Okay. So F to C is 1.21 miles. That is not at least 1.5 miles. At least means it's going to be that or more. Well, it's less, so didn't work. Okay, so now we're on to a volume question. Okay, so this portion of it says volume of the water tower. Okay, so we've got three pieces. When you spin this 180 degrees, you're going to get a cone. Spin this 180 degrees, you're going to get a cylinder. Spin this, not 180, I'm sorry, 360 degrees. And if we spin this, we're going to get what's called a hemisphere. All right. So basically, that's what we need. We need those three things. So for the cone, it's 1/3 pi r squared h. For the cylinder, it's just pi r squared h. Now, these h's could be different. Their radius happen to be the same. So we are going to use the 8.5, because if this is 8.5, then technically so is that, and so is that. All right, the hemisphere got to be careful here. That is actually going to be, I'm going to use just a sphere first, and then I'm going to cut that in half later. Okay, so volume is 4/3 pi r cubed. I'll use that formula, but then I will, adjust. All right, the trick, one of the major ideas on this problem is finding the height of this cone. Okay, the height of the cylinder is easy, it's 25. So we've got everything we need except the height of the cone. So let's start with that. We're going to need to perform a trig problem with this. Okay, and let's just call this the height of the cone, h. And compared to this angle, this leg's opposite, adjacent, and of course this is the hypotenuse. If I use my acronym SOHCAHTOA, it looks like nothing with hypotenuse in it. Opposite and adjacent, yeah, let's use tangent. Okay, so tangent of the 47-degree angle, whatever that is, should be the same as the ratio of the opposite side to the adjacent side. Okay, tangent of 47, that is what? 1.07 237. Now I always put that over 1. I like to do it this way, because tangent's a ratio of two sides, so that's a ratio. Calculator says this, so I just put it over 1. Now we have a proportion, and we can cross multiply. So h is going to equal whatever, 8.5 times 1.07. Get the cross products. That height's 9.1151, and so on. All right, so now we have all the pieces we need. Now we have to just go grind out this calculation. All right, not easy. So let's go back to the cone. 1/3 pi r squared h. Okay, it helps to write that down in case we make a mistake. We can always get partial credit that way. 1/3 times pi times, what was it, 8.5 squared, and times the 9.11. Okay, so when we calculate that, I get, where did that cone go? Yeah, 689, 651. Okay, there's your cone portion. Now let's do the cylinder portion. This is just all crunching numbers. 8.5 squared, and that, what did they give us? 25, right? That came out 5674. All right, and then the full sphere first. Careful, this cube threw off some of my students. So make sure that you're careful to cube, not just square. Most of them just squared it if they messed up. So it is 4/3 times pi times 8.5. I got to use this key in your calculator. If you have, let's say you have that TI Inspire calculator. If you use this key, it'll kick you up into the exponent. If you need to come out of it ever, just right arrow key out of it. Okay, so then that volume of the full sphere, don't forget, the volume of the full sphere is 2572.44. Okay, so then the hemisphere, we're going to cut that in half. Okay, so that volume is 128. Whoops. Sorry about that. Let's just get rid of it. So it's 1286, right? 0.22. All right, now you're going to come over here. We're going to add them all together. So the volume of the total water tower is, take all these numbers, and then be careful here, the 1286 is the number we're going to use. Okay. I don't know what just happened. Hang on. Okay, we got it back. I don't know, it just disappeared for a second. Okay, so that total was 7650.37. It did say nearest what? It looks like nearest cubic feet. So right there. All right, that's the total volume of the water tower. Now, there's a lot of other pieces of that. Okay, it was constructed to hold a maximum of 400,000 pounds. Can we fill it to 85% of its volume? Oh, and then there's that density part. Okay, a lot going on here. There's a few ways you can handle this. The way I happen to do it, it's not the only way. Please understand there's many ways to do this problem. I'm going to get 85% of that volume. Okay, I'm going to figure out how many cubic feet of that is first. So how many cubic feet is, so 85% full. What does that look like? We'll take up how much space? So I like to do it, you can do percent over 100 equals part over whole, and you can set up a proportion. I'm just going to multiply it by 0.85. 85% of usually indicates multiply. And then what I get there, where did it go? Yeah, 6502. Yeah, 6502.82. All right, perfect. So that's 85% full, takes up this many cubic feet of space. All right, now we're going to take a look. Oh, box that in. That's the answer to the first part. Now we're doing the second part. The weight of it. Let's calculate the weight. So I'm kind of keeping track, helping somebody understand what I'm doing. The weight of that has to do with density and volume. All right, so again, density, I know it's mass over volume in science. In math, we're not technical terms, but I'm going to say it's stuff over space. The space is the volume, right? Now they give us a density of 62.4. Is that pounds? Pounds for every 1 cubic foot. So you could put it into this formula. I like setting up proportions. It's just something that I tend to prefer. Science does a great job of dimensional analysis. If you'd rather look at that, there's probably some videos on dimensional analysis that might make it easier, but this is how I do it, proportions. So I have pounds over feet cubed, and that's your volume on the bottom, right? So I'm going to put our volume, 6502.82 cubic feet, all right? And then we're going to figure out how many pounds that is. So now, basically all this proportion tells you to do is whether to multiply or divide, and some of you can probably figure that out without doing all this. But whatever 62.4 times 6502 is, and when I do that, I get about 405,776. Okay, so here's what we then have to do. We can see that it's too much. So we have to answer the question, can we fill it without exceeding this weight limit? The answer is, let's answer it. Let's say no. We cannot fill the water tank to 85% without going over the weight limit. Make sure you answer the question. And hopefully that's enough to get us 6 points. All right, moving on. Let's see. Prove it's a right triangle. There's a few ways to do that. All right. So RST, let's go ahead and graph this. R is 6, -1. 1, -4. And -5, 6. Let me make sure. Oh, it went too high. All right, let me get rid of that. Come on. Okay, so let's label that. It's RST. Okay, prove RST. Hopefully you guys use a straight edge. Okay, we could get the length of every side, or I can see this is probably the right angle if it is a right angle. So I'm going to get the slopes. All right, to do this, I'm going to get the slopes of TS, and SR. It's good to let somebody know, whoever's scoring your paper, it's good to let them know what you're doing. All right. Be really careful on this. Either use algebra or count carefully. Let's see, I've got 10 for the change in Y. Let's make sure from between S and T, should that be right? Yes, that is a 10. And then, let's see, the distance across, I'm getting 6. From S and T, that is 6. Good. Okay, then I'm going to go to RS. Get 1, 2, 3, 4. I get 5 across, 3 up and down. Okay. So let's go look at the slopes. So first, TS, the slope. Okay, so I'm going to use rise over run. Algebra is great too. Formulas, you could always do y2 minus y1, x2 minus x1. I'm just going to use change in y over change in x. So rise over run. So I've got a change in y of 10, got a run of 6, and then you look for the sign. You move left to right, this is going down, so throw a negative. All right, I'm going to reduce it. It looks like I'm going to need to. So I'm going to take out a 2 as far as a factor. All right, I'm going to factor out a 2, and then those cancel. All right, divide out however you want to say it. Now SR's slope, that is going to have a change in y of 3, so a rise of 3, a run of 5. Yeah, so it's just 3/5. Okay, so let's talk about why that makes a triangle a right triangle. What we have is we have adjacent sides have slopes that are negative reciprocals. So I'm going to make a statement. TS is perpendicular to SR, and I'm going to justify it because their slopes are negative reciprocals. So in an analytic proof, this is the type of thing we want to work with. All right, you want parallel or perpendicular, you need to have slopes as your justification. You can't just make a statement without justifying it. Okay, again, there's another way to do this, but I think this is the easiest for me. So now what this gives me is angle S is a right angle. Okay, and that's because perpendicular segments form right angles. So let's number these just so you keep track of it. The third thing I'm going to say is triangle. What did they ask for? Is it RST is a right triangle. Try to keep it the same. RST is a right triangle because it has a right angle. Seems silly you got to say that, but it's you got to make sure you're clear. Get a good argument going together. All right, next. So that's probably worth 2, maybe 3 points. State the coordinates of P so that RSTP is a rectangle. Now, something we have to be really careful of. Okay? R and T in this statement have to make a diagonal. Okay, so that has to be a diagonal of the rectangle. RST, so these have to be sides of the rectangle. We have to come over here somewhere for that other point. Okay, it's just got to happen that way. You have to be in order. When they give you the arrangement of the letters, we got to stick with it. So, there's a number of ways to do this. What I'm looking at is from here to here, if I go right 5 up 3, I'm going to find a location, right? S to R is right 5 up 3. Well, T to P has to do that same thing. So I know that's not the, mathematically sound, but that is exactly what we would want to do. So I would go right 5 up 3. Something doesn't look right there. Okay, so that is the location of P. All right, zero, what does it look like? 0, 9? Yeah, 0, 9. Okay, so there it is. Now we have to prove that it is in fact a rectangle. All right. Uh, one of the ways we could do it, we already have one right angle. We could go ahead and calculate all four angles. So let's just, all we would need is two more slopes, right? So yeah, that's probably going to be our bet. Let's get the slopes now of two more sides. What is it? PT and PR. Slopes of PT and PR. Now again, you could use algebraic or go like this. Yeah, so that's up and down 3. Change in y is 3. The run is 5. From P over to R. If we did this correctly, our change in x, or sorry, change in y is 10. Our change in x should be 1, 2, 3, 4, 5. Okay, looks good. 6. So, what I say P to T is first. Okay, that is a rise of 3, a run of 5. It is positive because it's as we move left to right, it's going up. No reducing needed. P to R. The change in x is 10. The change in y is, sorry, the change in y is 10. The change in x is 6. And it is negative because it's going down as we move left to right. Take out a 2, factor of 2. And those knock out. Okay, here we go. We've got our list of all our slopes, right? So I'm going to continue with my statements. I already got S as a right angle. Let's get the rest of them. Okay. All right, so ST is going to be perpendicular to PT. Where is it? Sorry. PT is going to be perpendicular to PR. And RS is, we already did that one. PR is going to be perpendicular to RS. Again, this is because their slopes are negative reciprocals. Right? And we can specify what it is. 3/5 and negative 5/3 are negative reciprocals. Okay, and all the combinations of these have one of the two. All right. Um, all right. So now we can make these other statements. What are our angles? P, R, and S. So angle P, angle R. Did we already do angle S? Yeah, we already did. So what's the other angle we need? T. I should have done that one first. So angle T, angle P, and angle R are all right angles. Because perpendicular segments form right angles. And what is it? RS. Is it RSTP? Yep. So RSTP is a rectangle because it has 4 right angles. That's enough. So there's your proof. And that's the end of, yeah, that's it. That's the end of the June 2015 exam. And so go ahead and hopefully you'll, uh, you know, subscribe and like my page, like the videos, and hopefully this is really helpful to students. Thanks so much.